Hi, Math 105 student. This is just a brief video to show the essentials of quadratics from our 3.1 class. So let's start. A quadratic function, you should know the definition so that you recognize what they are when you hear the word quadratic. They are any function that can be written in this form: ax squared plus bx plus c, where a is not equal to 0. If a were 0, we would be left with just a linear function. We have to have that x squared term for it to be a quadratic. So that's our definition of a quadratic function, any function that can be written in that form. And that particular form is called standard form, the ax squared plus bx plus c. Quite often, these quadratic functions can be factored, not always, but quite often they can. And when they are, many times they look like that. Sometimes they only look like you're taking out maybe an x term, and so they might have some x term in front of another binomial. But that's factored. Many of ours right now actually will factor because it makes it a little easier to work with. You're given some contrived examples. So after you know what a quadratic function is, the next really important thing that we can do is graph those. And do you remember what the graph of every quadratic function is? That's right, the graph of every quadratic function. Well, before I say that, let's just take the most basic quadratic function, where a is 1 and b and c are 0. We'll just take x squared. That's your most basic quadratic function. Sometimes people call it the parent function. If we plot some points in here, like if we plug in, let's say -3, so we plug in -3 would be our input, and when we square -3, that is -3 times -3. Some people enter it like this on their calculator and they get -9, but that would be wrong. It's really -3 times -3, which is +9. And so we graph -3, 9. If we put -2 in, -2 times -2 is 4. So -2, the output is 4. So right there. If I square 0, I'm going to get 0. Now, if you think about patterns, if I square +2, I'm going to get 4 as well. And if I square 3, I'm going to get 9. So this is the basic shape of all parabola, or of all quadratic functions, which is called a parabola. Okay? And this is why it's a parabola, because of this idea that the same thing happens to the outputs when you go left of the vertex as when you go right. And it's clearly illustrated in the parent parabola, because if we square a -2, we get the same output as if we square a +2. So we get this nice bendy thing. Kind of bounces, hits the vertex, bounces back up, because it does exactly the same thing on the other side of that vertex. If a, the leading term, happens to be negative, that is, if I think about f of x being, let's say, -1 times x squared, like this, that means I'd be taking all of my outputs, like 9 and 4 and 1, when I do, I'd be making them negative. So here, f of -3, I would square that -3, but then I'd have to make it negative. Square and then negative, which would be -9. So this point up here, I've got to move this down now. This point up here, -3 would be coming down right here. And -2, 4 would then become -2, -4. So we get this inverted parabola if a was negative. or less than 0. So the parabola is a downturning parabola. If a is positive, clearly it's going to be upturning. But this is why. All parabolas have this point right here, that point right there. All of them have that point, and that point either is at a maximum or a minimum. If the parabola is downturning, like that red one is, that would have a max. That graph would have a maximum. And if it was upturning, that graph would have a minimum. Either way, these occur at the vertex. That's called the vertex right there. Just that point. Here, that vertex is 0, 0, but it changes depending on the function, of course. And a special line goes through that vertex. I'll draw that in here in pink. It goes right through that vertex, cuts the parabola in half. So we can see that the left side, this left side right here, is symmetrically the same as the right side. And you saw that when we plotted these points, because f of -3 is 9, but so is f of 3. So this point was symmetric to that one across the, you got it, axis of symmetry. The axis of symmetry goes through the vertex and divides the parabola in half symmetrically. So there are a few terms and ideas that you need to know. Vertex is one of them, axis of symmetry is another, and if the parabola has a max or minimum. Okay, so let's talk about an example to make this real and show you kind of things you'll be doing with parabolas. Here is an example of a quadratic function, and it is in standard form. There are a few things we know we can see directly from standard form if we're thinking about, I don't want the pink line here. Let's get that off. Line style, and we'll just use black. There we go. If we're thinking about a graph of this lovely quadratic, first of all, we know that it is a parabola because the graph of every quadratic is a parabola. The next thing that we know, since we have a negative there, because of what we just talked about, we know it's downturning. Okay? So we know we have a downturning parabola. So thus far we have this kind of thing. In addition to that, we also know one real easy point to calculate is if I stick 0 in for x. Remember the input is x, so I put 0 there and I put 0 in there. -2 times 0 squared minus 4 times 0 plus 6. It should be pretty clear. This is going to be 0, that's going to be 0, and I get 6. So 0 is my input, 6 is my output. That's my x, there's my y. I have 0, 1, 2, 3, 4, 5, 6. That point right there is my y-intercept. It is not my vertex, it is the y-intercept. So the standard form gives you the y-intercept. All right. It also lets you see clearly what a is, if a is positive or negative, telling you if the parabola is downturning or upturning. Okay. So let's see. Let me just copy this page here. I don't have my clone. So -2x squared, still looking at -2x squared minus 4x plus 6. Right? So that's in standard form, and we have the idea that it's downturning, and we have the y-intercept. We also know that we might try putting this in the factored form. The factored form may help us too, but let's just see. So the first thing I do in all factoring is take out a GCF, right? Take out the GCF. And I see -2 and everything else. So I take out a -2, and I get x squared plus 2x minus 3. And that's a quadratic that might be factored even further into two binomials. So I'll put x and x here. 3 factors into 1 and 3. One's got to be positive and one's got to be negative. Let's see, the positive 2x means that the 3 has to be positive and the 1 has to be negative. Then when I multiply out, I have x squared, 3x, -1x, and -3. So x squared, just checking, plus 3x minus 1x minus 3, and so that's 2x. All right, that's what I wanted to get, is x squared plus 2x minus 3. I'm going to erase all this other stuff so it's kind of clear. All right, now if we look at this form, this factored form, there's some easy points to get out of this factored form. You can see that if you put 1 in for x, I put 1 in, okay, f of 1 is going to be -2 times 1 minus 1 times 1 plus 3. You don't even have to calculate anything, but you can see 1 minus 1 is going to be 0, and the whole thing is going to be 0. Okay? F of, what's the other point that's easy? -3. So if I put -3 in there, I'm going to get -2 times -3 minus 1 times -3 plus 3. And I can see that's going to be 0. Up there, that one was 0. So these are easy points to see from your factored form. And what are they? Well, the input here would be 1 and the output is 0. Input over here is -3 and the output is 0. So what do these things mean graphically? 1, 0 and -3, 0. Let's take a look. -1, 0 and -3, 0 and 1, 0. Okay. Remembered that wrong from one slide to the next. So -3, 0 and 1, 0. If I plot those, -3, 0 and 1, 0, those are my x-intercepts. So the factored form provides the x-intercepts, but you have to kind of be careful here because some people would just take the numbers with their signs. I like to think that, you're just looking for the x value, which makes that stuff 0, because the outputs would be 0. So if f of x comes out to be 0, you can say, well, I can see that x would have to be -3 or 1. That's not an ordered pair. Those are really the x-intercepts just listed in order. Okay. And again, if I put 0 into this standard form, or even if I put it into the factored form, it doesn't matter, but it's easier to put in the standard form because you can see that's going to be 0 and that's going to be 0, and so we just get 6. All right. So I know I have a downturning parabola, and I've got these 3 points there. So it's really kind of nice. Right now, I can just kind of know that my my parabola is going to look kind of something like this. I don't know. This is a little tricky to draw here. Something like this, right? Okay. So let's do a little bit more and say, where's this axis of symmetry? Well, the axis of symmetry would have to occur halfway in between the x-intercepts. Since the parabola is symmetric, you're going to have an axis of symmetry halfway in between. So if I go halfway in between -3 and 1, that's going to be at -1. So I can, draw my axis of symmetry right there through -1. We write the full equation for this to be x equals -1. This is a line, and the x value never changes. The x value for that line of symmetry is always steady at -1 here. So we say x equals -1. Now the vertex is going to occur at that axis of symmetry, which makes sense because it's the maximum or the minimum right in the middle. It lies right on the axis of symmetry. So we know that its x value is -1. We take -1 and we put it back into the function. Whichever one you want to put it in, you may. I'm going to put it in the factored form just because I think that might be a little easier. So I'm putting -1 right in there. And I'm going to get -2 times 2, -1 plus 3 is 2. -1 minus 1 is -2. And I get -2 times 2 is -4 times -2 is +8. So my vertex is up here. I just undershot it a tiny bit with my graph, but my vertex is up there at -1, 8. That is a maximum because it's at the top. The maximum, it occurs at x equals -1, but the maximum actually is 8. We said it's a high value. The maximum is 8. Okay? So again, things to pick up from here are key points. F of 0 is 6. If f of x equals 0, how do you get the outputs to be 0? You look at the factored form. What makes those factors equal 0? And then you should know the axis of symmetry cuts it in half, and the vertex lies on the axis of symmetry, and you just plug the first axis of symmetry value in for x and calculate your y value. This isn't something you need to memorize, but it is something that is nice to understand and figure out as you go. So now we'll just go the other direction. Here is a function that's given to you in factored form right there. It is a factored form of a quadratic. We can see that if we multiply it out, we get that x squared. There's a coefficient of 1/2 in there. I'll just multiply it out just to kind of show, but I don't really need to for what the questions are asking. I have x squared, and then I have -6x, and +4x give me -2x, and then a -24. So this will multiply out to be 1/2 x squared. 1/2 times -2 is -1x. 1/2 times -24 is -12. So I'm asked to graph this. I look at this and I say, what would make these? What would make f of x equals 0, what would I put in for x to make the output 0? And the answer would be, I'd have to put in -4 for x. So I know -4 is a root. 6, 1, 2, 3, 4, 5, 6 is also a root. I say root 0 and x-intercept are all synonymous terms. Okay, so those two are my x-intercepts. By the way, since we already did this, since you multiplied it out, you should know -12 is going to be your y-intercept. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Boom, right there. Not the vertex, that's the y-intercept. You can see that because the vertex is going to lay halfway in between. And since I have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 in between there. My vertex is going to have to be 5 from each one. 1, 2, 3, 4, 5. It's going to have to be right on this line right here. Make that dotted line. It's going to have to go right through 1. Right there. There's my axis of symmetry. I like to make it a dotted line because it's not part of the graph. It's just this imaginary line cutting the parabola in half. So my axis of symmetry, we say, is x equals +1. X equals +1. Okay. So the vertex would have to be 1, comma, and now I put 1 into either form. I'm just going to put it into that second one. 1 plus 4 times 1 minus 6. So this is 1/2 times 5 times -5. So that's -25 halves. That sounds like negative, what is that? -12.5. So it's a little lower than your y-intercept. Right there. -12.5. So 1, -25 halves is my vertex. And so the parabola goes something like this. There, this is not the greatest graph, but like that. That parabola has a minimum, low point right there. Where is it? It's always going to occur at the vertex. And what is it? That's the y value of the vertex. So that would be -25 halves. So those are two brief examples. I hope they help kind of recap the main ideas in 3.1. Good luck. I should finish stating this one right here, vertex. There we go. Have a great day.